So we will continue, we will start today problems on chapter 16. And before I will just introduce the main formula we will use and do practice on each of them. So first, concerning the shearing operation, cutting operations, uh, in sheet metal cutting, we can have shearing, we can have the case of, as we will see, punching and blanking. Okay, so to start with, the process parameters in sheet metal cutting are clearance between punch and die, the stock thickness, and the type of metal and its strength and length of the cut. And we will define together in this session all of these parameters. So first, if you look at the figure here, this is a shearing operation. So as you can see, the die is the fixed part on which you put the work part, and then the moving punch will allow to do the cutting operation. So here cutting is performed by shear, and as you can see, you have here a certain small clearance between the die and punch to have to allow a smooth operation. Okay, so the value of the clearance between the punch and die will depend on the material used and its thickness. Okay, this is why the clearance is given by AC times T, where C represents the clearance in millimeter and AC represents the clearance allowance. And AC you can get it from a table. Okay, so each material will have a specific clearance allowance, and then from the thickness of the stock you can get the value of the clearance required for the shearing operation. So here, for example, you can see here a table that will give you, depending on the metal group, what should be the value of AC. Okay, so in general, if one of these materials is given in the exam, you should know how to go to the table and get the corresponding value of AC. And if another material is given, they should give you AC with it or give you the corresponding table. So the clearance C in shearing operation represents the distance between the punch and die, as we have seen together. In general, typical clearances in conventional press working will range between 4% and 8% of the sheet metal thickness T. So it's as you can see, the smaller the clearance is very small compared to the thickness. Now, if we have improper clearance, we should optimize the clearance, because if the clearance is too small, then we can have fracture lines that tend to pass each other, which will cause a double burnishing and larger cutting forces. On the other hand, if clearance is too large, the metal becomes pinched between the cutting edges and an excessive burr results. So let us see the figure to understand more. As you can see here, so if you have a very small clearance, this will lead to a fracture and excessive forces acting on the work part. However, in case clearance is too large, then the cutting operation will not be good and you will have oversized burn in this case. So this is why we should optimize the value of the clearance from this empirical relation, C equal AC times T, where AC is characteristic of the metal used. Now, we have also, so this is one type of cutting operation, the shearing operation. You can have also blanking and punching. Okay, what do we have in case of blanking and punching? So as you can see here, this is also a shearing. These are types of shearing operations, and they consist on cutting, if you want, a part of the metal. Now, we can have this operation can result in two pieces. So here, initially, this is your stock. So it is, let's say, in this form. Okay. Then, when you will move the punch through the stock part, what will happen is you will produce a hole in the stock part. Okay. So here you will have a hole produced due to the motion of the punch, and then you can the final product can be or the cutted part. So in case the final product is the cutted part, which is here. Then this is blanking operation, and this is called the blanked piece. On the other hand, if your purpose is just to produce a hole uh, into your work part, then the final product will be the part with the hole. Then it's a punching operation. This is why we say that in punching operation, it is the punch that will impose the size of the hole. However, in a blanking operation, it is the die that will impose the size of the blanked piece. So as you can see here in the figure, for the blanked piece, this is the size. This is the size that you will have, and it is equal to the die size. On the other hand, in case of holing, when you want to do a hole, then you have here the dimension of the hole will be imposed by the punch. So in punching operation, you will set the punch dimension equal to the hole dimension. Whereas in the case of a blanking operation, then the diameter of the blanked piece will be equal to the die size. Okay, so here we can see the difference. So here we have the corresponding equations. So in case my purpose is to take the blanked part, okay, so if I'm doing a blanking operation, it is the die that will impose the blank part size. So this is why the blanking die diameter will be equal to the diameter of the desired part. However, in this case, how to determine the blanking punch diameter? As you can see in the figure, you have to subtract from the die size 2 times the clearance, because you should have a clearance from this side and from this side. So in total, the blanking punch diameter will be equal to the die diameter minus 2c. On the other hand, when you want to do a punching operation, so your purpose is to determine the whole diameter, then the whole diameter will impose on you the punch diameter. And then from here, you can determine what should be the die diameter, which should be dh plus 2 times the clear. So at the end, it will depend on what is the part that you desire to take. It is the cutted part or the remaining part. Okay. Now, in case it's a blanking operation, the cutted part is called blank. Okay, it's the blanked piece, and the remaining part will be the scarp, so we don't need it. On the other hand, if I have a if I have a punching operation, then this part which is cutted will be called slug, and the desired part will be from the sheet stock. Okay. Now, in order for the slug and blank to drop through the die opening must have a certain angular clearance with 0.25% to 1.5% on each side. This means that it will not be perfectly straight. Okay, it will have a certain clearance to have a better operation. Any question on this? Okay. Now, concerning the cutting forces, in general, the cutting forces can be estimated by the shear stress times the area on which shear is applied. So you know that here we are in cutting operations, we are based on shear. Okay, so the cut will be done by shear. This is why the shear forces can be computed as the shear strength times the area over which we have the operation. And in general, the shear area can be calculated as the area through which we have the cut. Okay, so this area will be equal to the thickness of your stock, okay, times the perimeter. Okay, because if you look at your cutting operation, it will take place over this area, the perimeter times the thickness. So this is the lateral area through which the cut will be performed. So here, if I represent it, so it's like this. Okay, so this is my area of interest. this is the shear area. Then my force can be calculated by the shear strength times the area of cut, which is T times L. Now, sometimes if we don't know directly the shear strength, but we know the tensile strength, we can compute the shear strength, as you know from previous chapters, by 0.7 times the tensile strength. But pay attention, if they give you both, and if they give you the shear strength and the tensile strength, of course you will use the shear strength, because this is an approximation. So if you want to be very accurate, if you know the value of shear strength, use it. If not, you can use this approximation. Okay. Now, these equations for estimating cutting force assume that the entire cut take place along the sheared edge length L at the same time. Because you know that in general, this is not true. Because in the cutting operation, as you can see in the figure here, we have a certain angle called shear angle, okay, which will allow to spread the cut over a certain time, which will reduce the force experienced at any moment. But uh, in both cases, the total energy required for the operation is the same. However, instead of what will be different is the time of operation. So if you have a certain shear angle like this, okay, then you will cut يعني in smoothly يعني you will cut not at one moment يعني you will have a larger time step to do your cutting operation, and this will allow you to reduce the shear force acting at a certain instant. But at the end, this will take more time. It will take more time than if you have a zero angle, because if the angle is zero, then you can at the same time have do this force instantaneously everywhere. Wherever here with the angle, you will do your cut in a smoother way. So at a certain instant, the force will be lower, to which the work part is subjected. But since at the end you want to do the cutting operation, you need the same total energy. Okay. So in general, when we design, we consider that we will design based on the maximum force to be on the safe side. Yani. We say that we calculate based on that the force is applied at one time over the whole cutted part. This will allow us to determine what is if you want the press capacity that we should use. But in case we are having a shear angle, it's not a problem because the force will be lower, so the press will be able to do this operation. Now, concerning, so this is the part for shear forces and shear operations. We will do some problems on it, and maybe next time we go over analysis of them. So let us start now the problems related to this part. A power shears is used. A power shears means this is the machine used for shearing operation. Is used to cut a soft cold rolled steel that is 3.2 millimeters thick. What is the clearance that the shears should the shears be set to produce an optimum cut? So here you have first the type of material used. This will give you what? This will give you the clearance allowance, AC, and you have the thickness of your stock, T. So this information will help you to get the clearance. So AC times T is equal to the clearance. Okay. So this is just a direct application to know how to calculate the clearance in a shearing operation. So first you go to your table, you search for the type in the problem, which is here. You have soft cold rolled steel. Okay. So the AC will be 0.06. You select it, and you have the value of your thickness. You can get the value of clearance. Of course, in a problem, this will be a small part of the problem. Just it is here just for you to know how to apply. So the problem will be in this type, okay, as you can see here. A compound die is used to blank and punch a large washer out of 6061 ST aluminum alloy sheet stock of 3.2 millimeters thick. The outside diameter of the washer is 25 millimeter. and the inside diameter is 12 millimeters. Determine the punch and die sizes for first the blanking operation and second the punching operation. So here your final product should be of this. This is the geometry of your final product. I will illustrate it here. So you have a cylinder with a hole. Okay. So this is your cylinder, and this is the hole inside. You have a hole inside, okay? And they gave you the diameter, the inner diameter and the outer diameter. So here to produce this final product, okay, you can do it in several ways. You can do it by first doing blanking operation to obtain the outer part, then perform punching operation to have the smaller one. Okay, and also you can do it by just a blanking operation if you if you design a certain die and punch in a way that the blank part will have this cross section. So you can have it only in blanking operation. Okay, but here they told us that they want to fabricate it by using first two operations, blanking and punching. Now, but we can do these two operations at the same time, okay? Or we can do each one separately. So they are saying that first determine the punch die size for the blanking operation and the punching operation, okay? So what we will do first, for the blanking operation, we will obtain what? Which part? So this is the outer diameter equal to 25 millimeters. When you perform the blanking operation, what you will obtain? The blanking operation will give you what? Who will tell me? Yalla. Joe? Joe, Karim, or Muhammad, what will the blanking operation give me? We said that the blanking operation, okay, will give me the outer cylinder, okay? So the cylinder of diameter 25 millimeters. So this is why I will consider that in case of blanking, okay, my purpose is to obtain the cylinder. Guys, are you hearing me? Okay. Okay. So in the blanking operation, we will obtain the cylinder of diameter 25 millimeters. And therefore, in this case, we have that, because I cannot hear you if you are talking. Maybe there is a problem. Are you talking with me and I'm not hearing you? Can you please try to talk to see if there is a problem? Because I can't hear. Okay, anyway, I will see what is the problem after. So let us, if you have any question, type it in the chat, okay? So here, concerning, as we said, in the blanking operation, what will determine the size is the die, okay? So we said that when we have a blanking operation, the diameter of the die part, so D of die, will be equal to the desired diameter of the part. Okay, so here in the blanking operation, the die should be equal to 25 millimeter, while in this case the punch should be smaller, should be d die minus 2 times the clearance. So to find the punch size in case of the blanking operation, we should determine the value of the clearance. Okay, so the first step here is to determine the value of the clearance. We know that the material used is this type, okay, and the sheet stock thickness is 3.2 millimeter. So now from the table here, we can get it from the table. So if we go to the table, the same table we used before, okay, for this type of aluminum, then the corresponding AC is also 0.06. So here you have several metal groups sharing the same AC. It is 6061 ST aluminum alloys, brass, soft cold rolled steel. So all of these will share same AC, which is 0.06. So in this problem, the value is 0.06. Now, once we find the value of the clearance, as we said in the blanking operation, okay, the diameter of the die should be equal to the diameter of the desired work part, which is 25. On the other hand, the blanking punch diameter will be die size minus 2 times the clearance. So we can calculate the corresponding blanking punch diameter. On the other hand, for the punching operation, the purpose of the punching operation is to produce a hole in our cylinder. And after getting your cylinder of 25 millimeter, you want to produce a hole in it. So now you will perform a punching operation because the cutted part will be it's the scrap part. I don't want it. Okay, so here what will determine the punch size will be the size of the hole. The size of the hole is 12 millimeters. So we can say that in this case, for the punching operation, we have that the punch diameter will be equal to the work part desired, which is, I should have a hole, which is 12 millimeter. And in this case, to determine the die diameter, I will take the punch diameter and add to it 2 times the clearance to get the final punching die diameter. Okay? Any question on this? So please type your questions in the chat, please, if you have a question. Okay. Another problem. A blanking die must be designed to blank the part shown in the figure. The material is 4 millimeters thick in stainless steel. Determine the dimensions of the blanking punch and the die opening. So here, this is a little bit more complex. Okay, so you have, this is the final desired cross-section of your part. And you want to produce it using a blanking operation. Okay, and we want to determine what will be the dimensions of the blanking punch and the die opening. Okay, so first, because it's a blanking operation, we know that the die should have the same dimensions of the blanked part. So the die should have this cross section. It's sharing the same dimensions, 25, 25, 50. So it is the same pattern. Okay, and here the height should be the difference between 85 and 50. So this height is 35. Okay, now on the other hand, what will be the dimensions for the punch? You know that always between the punch and die you should have the clearance. Okay, so here if I want to illustrate what should be the geometry of the punch, it is like this. So first I should take a distance from each edge equal to the clearance. So this is C from here, this is C from here, etc. From all sides, I should have the clearance. So if I want to draw the blank cross section, the punch cross section. So first it's like this. I go a certain distance C from the edge. Here also I go C. So it will be like this. So this is my punch. Okay, and we will calculate together the different sides. What is the dimensions of the different sides? Karim, no, it's not the hole whose thickness 25. The thickness in the previous problem of the hole is 12. Okay, so if I go back to the look here in this problem, okay, you want the whole size is 12, while the outer size of the cylinder is 25. So when you the first step you do, you make your cylinder. When you make your cylinder, it's a blanking operation. So because in this case, okay, the cutted part from the operation is desired, which is the cylinder. So in this case, 25 millimeter will be the diameter of your desired product in the blanking operation, and it will be the cutted part. This is why it is 25 is determined by the die diameter. Once you obtain this part, you want to perform a hole in it. So the hole, the part which will be, if you want cutted, will be the cutted part will be rejected. So it's not you don't want it. This is why it's a hole. It's a punching operation because you desire to produce a hole in your work part. So when you want to produce a hole, then it is a punching operation, and the size of your hole will be determined. So 12 here is the size of your hole, this hole, okay? And the size of this hole will be determined by the punching, will be determined by the punch, okay? In case of a punching operation, the hole size is the punch diameter. In case of blanking operation, the size of the desired part will be the die dimension. Okay? Is it clear, Karim? Okay. So let us go back to the to our problem. So the red line here, okay, this is the red line which correspond to the cross section of your punch. Okay, so here what will be the size of my punch, the dimensions? First, for this line here, it is, as you can see, you have a clearance from this side and a clearance from this side. So the length here will be 50 minus 2 times the clearance. Okay, the same for the length here. It's also 50 minus 2c. Now, concerning this part, the big length, it is 85 minus 2c. And for this one here, these two, this is 25 minus 2c, these two. So 25 minus 2c. Now, concerning these parts, these two, who will tell me? What will be the length of these two parts? These two lines. They will change in dimension, these two lines. These two. What will be the length of these two sides? If you look well at your figure, okay, you have that, yes, exactly, Joe, it's 25. Why? Because you have here that the distance this distance is equal to C. Okay, and so you are doing 25 minus C, but then you will add it from the other side plus C. So 25 minus C plus C, it is 25. So for these two sides, the length will not change. It is equal to 25. Okay, and then the remaining part is this one. Okay, already once you determine all the other lengths, this will be direct. You can calculate it directly, or you can say that it is equal to 35 plus 2C. Okay, so this will be 35 plus 2C. Okay, so these are, now all we have to do is to determine the clearance C. So we know that the type of the material is given, and we have the thickness. So we determine the value of C, then we will be able to draw the dimensions, to draw the cross section and determine the dimensions of the punch. Okay. Any question on this, how we determine the dimension of the punch? Okay. So let us see here the solution. So as we said, the first step, we go to the table. We look at the type of material. Here the type of material is half hard steel. So if we go to the table here, we have here, this is the type, half hard steel is in this line. So the corresponding value of AC is 0.075. Once we determine this, we can go back to the problem. Knowing AC and the thickness, which is 4, we can get the value of the clearance. Now, for the blanking die, the dimensions are the same as for the part in the figure, because as we said, in a blanking operation, the desired part dimension will impose the blanking die dimensions. On the other hand, for the blanking punch, we determine it from the figure by taking into account that we should have a clearance between all sides. So as we did together, for the 85 millimeter length, we should subtract 2C. For the 50 millimeter width dimensions, we should also subtract 2C. And for top and bottom 25 millimeter extension width, also we should subtract 2C. We have only the 25 millimeter inset dimensions that will remain the same. Okay, here I didn't calculate this one because this one already, once you determine this length and these two, the remaining one will be imposed. Okay, this is why they didn't calculate it. Okay, but in all cases we did the calculation. It is in the for the blanking for the in case of blank size, it is equal to 35, while in case for the die size it is 35, while for the punch size it is equal to 35 plus 2C. Okay, because here you have 25 minus 2C, and here also you have 25 minus 2C, while the total length is 85 minus 2C one time. So this length will be equal to 35 plus 2C, and we have seen also this in the figure, because if you want to draw it, you should take a clearance from two sides. So you have here 2C, okay, and you have here 2C. So you will have C from this side and C from this side. So in total, it will be 35 plus 2C. Okay. So any question on this before we move to another problem? Okay. Another problem. Determine the minimum force capacity press to perform the blanking and punching operation in problem 16.2 under the following conditions. First, blanking and punching occur simultaneously, and second, the punches are staggered so that punching occurs first, then blanking. Okay, so let us go back to the problem, problem 2, and this is what we talked about together. So here, in this problem, your desired final product is a certain cylinder with a hole. Okay, so we said that we can perform this operation in several ways. We can first do, for example, the hole, then do the blanking operation, or we can do first the blanking operation, then the punching operation, or we can do them at the same time. Okay, what will be the difference in this case? Who can tell me? If I ask you for the press capacity, okay, which operation will need the highest press capacity? If I do the two operation at the same time, or if I do one after the other? What is the expression of the force required? The force required is equal to the shear strength, okay, which is here the same because it's one material, times the area of shear, which is the thickness, times the contact, the perimeter length. Okay, so here first you have that the material is the same for both. Okay, you have the thickness is the same, so the criteria will be the length. Okay, so yes, Karim. As Karim said, if we perform the two operations at the same time, the required force will be higher. Why? Because you can see here that the force is proportional to the length of cut. Okay. When you perform, if you perform just the blanking operation first and then punching operation, or punching then blanking, so the press size will be imposed by which operation? The blanking or punching? You are using the same press, okay? So one press will have one maximum capacity. So since this press should have a minimum capacity to perform this operation, so who will impose the minimum force of the press? The blanking operation or the punching operation? If you are doing them separately, you should compare what is the cutting length in the blanking operation and the cutting length in the punching operation. We have seen that to perform the punching operation, we produce a hole. So the length of cut will be this one, 2 pi r, or pi times the inner diameter. Okay? While for the blanking operation, we have that the cut length will be pi times the outer diameter. And you know that what will impose the capacity will be the highest length. Okay? So if you want to do, if you don't want to do them at the same time, then your maximum capacity will be depending on the this size, which is the blanking length, and based on it you can calculate the corresponding minimum force required, because of course the punching operation will require a lower force, since L of blanking is higher than the cutting length for punching operation. Okay, on the other hand, if you want to perform both at the same time, of course you need a higher